Hi, my name is Steve DiPaola, and I'll be talking about our paper using artificial intelligence techniques to emulate the creativity of a portrait painter. The paper is by myself and Graeme McCaig. We're from Vancouver, Simon Fraser University. So we're going to present three new AI machine learning techniques that add abstraction and semantics to our already available suite of painterly techniques. So this is in the area of computational creativity and non-photorealistic rendering, and it has application in entertainment, health, education, and we have other papers at EVA that discuss the application space. These particular techniques are more cognitive in nature. They deal with aspects of dreaming and semantics, imagination, and internal abstraction. Um, so in this case, there's the painter mode, which is this middle one, and a lot of abstraction could happen at painting time, but these are really to think about a mental representation before you're actually committing to the paint. What's in the head of Picasso when he thinks of a particular shape before he just starts painting. So we want to put these systems on top of our painting system, which is called Painterly, and we have several papers on it. And it tries to model the cognitive process of artists using algorithmic particle systems, noise modules, but mainly understanding the deep creative way that painters paint. Um, but with these three new techniques, we want to add these thinking about what to paint first before you actually go. So it's a pre-painting system. They all use a neural network or a deep learning network, and these understand how to balance and blend different aspects of aesthetics, the conceptual and the abstraction layer, and even the semantic level layer. Um, so they're a bit different than some of our other techniques. So let's just show you the standard things we can do already with our systems where we're really thinking deeply about the painting process, uh, light and darks, warm and cool colors, teaching it about what a face is, what a background is, being able to take historical palettes like from Hopper here in the lower left and rescale it, its luminance, its color, its literally its conceptual blobs, its passes, its range, its edges, in kind of a rather deep way. So we've done a lot with this particular system already, and we've used it to show the kind of the genius of artists, how Rembrandt uses a lost and found edge, how it moves in here and can move right to the dominant eye to tell this deeper story about the inner life of this person, more from that. And we have several user studies and experiments detailing how Rembrandt really owns your eye uh, um, using these techniques. Here's more of these. So we want to add to these techniques with these three new neural network approaches. So neural networks is in the AI domain of machine learning or cognitive science. Neural networks are families of techniques inspired by biological neural networks, that is the central nervous system of the brain. They're interconnected neurons. I'll show you a graph in a second that are layered at different levels from low level to mid level to very high conceptual level. And we use functions and numeric weightings in the artificial version of it. And it really makes it very adaptive and capable of learning on its own. Two of these systems use a very large neural network, which are now called deep learning, which is very in and is being used in very significant ways. So you can see there's some level of training with hundreds of thousands of pictures. It learns from those pictures, and then we're able to bring in a subject and other levels of semantics, like textual semantics, to generate the work. Here's a kind of a typical look at the neural net. At the very lowest level, the bottom level, pixels come in, and it's emulating the way the visual cortex works. So it goes from pixels to edges, and oh, there's a bright spot in the middle and dark around. So it has these patterns. Those patterns are used to at the next level up, which could start being oh, something that kind of looks like the leg of a bird, or other pieces that could be put together, and then higher and higher, putting all that together and saying, oh, this is a car or a bird or a human. So that's how the system works. Uh, it uses, a lot of them use ImageNet, which is 100,000 images, and it does this level of labeling like a container ship or a leopard. And you can see it's mainly trying to just categorize pictures and learn from it. So when you give it a picture that it doesn't know, it should be able to categorize it, right? And they use this in Google Street View, and knowing, what's a person and they should blur out the face, or what's a stop sign, or and such. Um, we're using it in newer ways where we're generating back down, and we're also trying to bias that with computational aesthetics in mind. So getting emotion, style, quality is what we're after. So let's look at the three different techniques. The first one is a planar or cubist based abstraction. So many AI and NPR systems, they abstract at the painterly level. They just vary the stroke length and some of the other variables. This is a reasonable way to do things, but it surely isn't in the mind of the painter. You can't get Picasso level abstraction just by varying things. So our system is more advanced. It uses a regressor based image stylization based on genetic algorithm, but it rephrases the problem with this much speedier machine learning technique. So I'll show you what some of that looks like. Um, so we can get different levels of abstraction, some from very severe, like down to almost three different planes in the plane abstraction, all the way up to hundreds of planes. So you can see the different looks. We have 7 here, but we could have any number of looks, and we're able to change this on the fly. The actual neural network system, the inner abstraction, looks like here on the left. It's quite solid, and it's getting the planes right, but it's when we put it through the implementation phase where it goes to our paint release system, where we're doing texture and stroke. You notice we off kilter everything in a more human looking way, and we're putting in different level of edges. So we do this for every part of the system. You never really see this internal one, but there is that internal. So here's some of the looks we're able to get. You can see it's my face here, um, and we can go, in some ways, we're going more and more severe in the style. And this is some of the looks and more of the looks. So we're going to move on to the second one. This is Deep Dream that was developed by Google very recently, but we're changing it and using it in different ways. It's got 2 modes. It's got this free hallucination mode that begins with the source images and uses a back propagation and gradient ascent to gradually transform the image to emphasize these strongly activated features, again at different levels. So let's look at that. Um, Again, if you're these are kind of low to mid-level levels, so we're really seeing more patterning. Still my face, um, and you can see this green one is at a much higher conceptual level, so we're almost seeing the labeled data showing up, like chickens and dogs actually coming out of my head, and we can get very painterly looks, as you can see. There's also a guided image where as it back propagates and does the gradient descent, you actually have more of a hallucinatory image, and it's really trying to balance between the image you gave it and how it labels it, and this new secondary image that has nothing to do with how it originally labeled. So here you can see we're using a butterfly, and it's balancing the butterfly at a particular level with my face. Here it's a volcano at this mid-level, and you can really see the sense of the volcano coming out of my head. Here is a bird at this mid-level, a fire truck. So it's a very different kind of approach. This bee is quite interesting because it's really trying to do the legs of the bee, but it's using, you can see what it knows and what it's learned, which is dog legs and dog hair, to do a good job on what looks like kind of a furry bee and other looks. Um, Here is my face matched to a car. So really blending Volkswagen Beetles in my face. Uh, and then we've seen this bird, and this is at the mid-level, so we're mainly getting feathers as opposed to birds coming out of my head. So let's move on to the last one called Deep Style. This is similar to Deep Dream. However, notably, it optimizes an image based on multiple networks simultaneously. So it actually takes a lot longer. And it has a secondary style image. And it's capturing the color, the texture, and the style from that one image and then putting that on my face or the main source image. So here's my face again. And this is an actual photo of a painting of George Bush. So this is not from our system, but now we're using this to take the style out and put it on my face. And again, a different real painting, and then putting that on the source face, and a different painting in my source face. And again, and here's Lucian Freud. And I think this is one of the better ones that came out. I like to say it really gets the style down, but it puts it in the wrong place. There's more work to be had. Like I wouldn't have put all this on the forehead. So it seems to surely know how to grab style, but it doesn't know enough about what a human face is. We're taking the Van Gogh and back to the Rembrandt that we've had. So this is quite a significant technique. So I'm now just showing you that concludes. We're showing you the three different techniques that we have and how we can put them all together. This planar technique we've been using in abstract movies in ways that we bring the abstraction up in plays. Um, the last thing I'll mention is we're also looking at now with ethnographers and people who do documentaries because especially for instance working with a native group or an ethnic group uh, um, that wants to maybe tell their story without showing their actual face. So the way people anonymize people in interviews is with pixelation or other techniques, and we're able now to use these more painterly and abstract techniques to actually show off the emotion that's on the face with still anonymizing it so you can't exactly see who it is. So this gives you a taste of our newer AI systems that we've brought in. Um, uh, if you have questions, just email me at DiPaolo, my last name, at gmail.com or dipaolo.org/EVA16. If you go there, you'll find this video and other information, and I surely can Skype with anyone. And these systems are available for use, so if you're interested in playing with these systems, you can do so. If you go to the website, you'll see some of the large art movies that we've created with these systems that have been actually getting a lot of play. They look very different than the kind of standard deep dream creatures coming out of people's heads because we're emphasizing more uh, the art side of things. Okay, thank you very much. My name is Steve DiPaolo, and please email me with any questions.